Welcome everyone. Welcome to my new YouTube channel, Z Network Lessons, and welcome to this course of Cisco ASA Zero to Hero. And in this video, we'll be talking about the NATing concepts. So, in our earlier videos, we have done the basics. Basics of ASA. We have covered the basics of ASA, how ASA works, the flow, and uh, the management and also the routing. Right, we have covered that routing, whether it be static routing or the dynamic. So we have covered static and dynamic. So now in this video, what I want to cover is the NATing. Okay, NAT stands for network address translation, right? Address. And for the people who don't know, let me just explain what this does. So this helps us to convert the public IP, or you can say the private IP to public IP, private IP to public IP masking, you can say, or translation, masking, or you can say translation. And this translation actually helps us in couple of ways. One of the way is it helps us conserving the usage of the public IP address of public IPs, because in a way it helps us in cutting down the cost as well, cutting down cost, because these public IP addresses will cost you money, right? So this will cost you money, and also this will provide you security in a sense when your internal IP is masked with external IP address, and then the public cloud that we have, where you have billions and billions of people. They don't get to know the addressing scheme that you're using inside your LAN, right? So that is again a kind of security that you get when you use NATing. Now, what is the concept of NAT? Let me clear this. So basically, what happens? You use the private IP address range, whether it's from the 10 range or whether it's from the 172.16 range, right? Or whether it's from the 192 range, right? Whether it's from the 192 range. So you have these options, right, to use the private IP address scheme inside your LAN, right? So you can use any of these, but you cannot use this IP address to access the internet, because these addresses are blocked on the internet. Using different methods, you can have simplest would be you can have an ACL on the ISP side saying block these ranges, right? Short story, that this is blocked, and you cannot use this IP address to reach it. So now, in order to use the private IPs inside and use the same IPs to get to the internet, what we do is we take advantage of the NAT. And how it helps is you basically translate the IP addresses of the private range to the public IP, and on the public side you are represented with that public IP that you have been translated to. For example, let's take a scenario here. R1 is actually 10.11.11.1, right? So this is the IP of the R1. Now imagine it wants to go to any IP address on this range. So just think this is a Telnet packet. Okay. Let's see, Telnet source is R1 and destination is, let's say, 192.1.20.2, which is R2's address. So what happens on the ASA is it checks the the policy but as now we are going from the higher security level to the low security level, and this is a TCP based packet, and this will be allowed. Once you go out, so these two networks are directly connected, and it knows to go to 192.120.2. I have to go through the ether 1 interface. Once the packet reaches R2, R2 checks its own routing table, and it sees that, first of all, it sees that this packet is destined to me. It will open up and see I have to send the reply back, right? So now it will flip the source and destination. Now the source and destination will be different. Now the source will be R2, this time 1.20.2, and the destination is 10.11.11.1. Now there the problem lies, because in the real time you will not expect your ISP routers or devices to know your internal IP address or have any routes, static routes to those addresses. So what will it do? It will drop the packet there. Okay. In our earlier cases, what we had a static route here defined, which said if you want to go to 10.11.11.11.0 with /24, go to the IP address of the AC. But that was for the lab purpose. But in real world, this is not the case. So how you solve this issue? Okay, what you do is you configure NAT on the AC. But specifically, we are going to talk about the auto NAT, and that too is actually dynamic NAT. Okay, this is part of the dynamic NAT. Comes in the category of auto NAT, but it's again subcategory of dynamic NAT. And then this can also be called as object NAT, because we will be using objects, and you will see how this is called object NAT. So now in this case, what we'll do, okay, let's imagine the same traffic. Okay, R1 sending telnet traffic to, again, R1 is 10.11.11.1 as the source, and destination 192.1.20.2, right? So now in this case, you have the source and the destination as it was in the earlier case, but now the ASA will be doing something called NAT. Okay, now NAT, in NAT, what it will do is it will create a pool of the public IP. So I have say a range. I will show you how to define this. Just try to understand. So I'll have a range of public IP address. So for example, we have this 20.0 range, right? So imagine I have the addresses belonging from 11 to 50. Okay, 192.120.11 to 20.50. So that is the range. That again, I'll create another pool which will specify the internal subnet. So I can say subnet. So this is my 11.11, which I want to actually translate. Okay, so I'll specify the whole subnet. I can also specify this subnet. So we'll see if I do only this subnet NAT, this will be able to go to this address, but this will not be able to go. Okay, so that is the subnet. Then you define a NAT statement. How you do it? You need to understand this. So you say NAT. First, you create the pool, and inside that internal pool, you define the NAT statement. So you say inside NAT, and then you have to specify two interfaces. So it's always, 99% will be doing the source NAT, and you will see this as the high level interface and high security level, and then the low security level interface. So in this case, this will be my inside, and this will be my outside, like that. So you have the inside and outside, and then here you define the dynamic or the static nature. So dynamic, and then you define the pool that you have here. You have to name this pool. Say my pool. Okay, so you say my pool here also. So you point this, NAT to this pool. So anybody from this pool, when going outside, will have a IP address from this pool dynamically assigned. So now what happens? So for example, now let me take another. So now this is the packet from the ASA. So now on the ASA, you have a statement saying any IP address going for this pool pool will be translated to any IP address from this public pool dynamically. So what happens here is now the packet will be changed by the ASA. So now the source and destination will change. So it will be the AC will be changing. The source here, in this case, you have the 10, 11, 11, 1. Now it will go as 192.1.20 dot something. So we have 11, let's say 12. And then it is going to the same destination, which is 192.1.20.2. So this is the packet that reaches the R2. Imagine our R2 sees that, okay, this packet belongs to me, let's open it, and the source is 12, so I have to send a packet back to 12. Now source is me, 192.1.20.2, going to destination 192.1.20.12. So in his routing table, he knows that to reach to 192.20.0, I have to go on the gig 01 interface. So it sends the traffic back to the ASA. Now ASA has a translation table, right? So now it will do the untranslation. Now it will do the untranslation. So now the packet looks like this, which is ASA. ASA looks at the natting, translation table and says, okay, so the source remains the same in this case. Now the destination that was 12 has to be changed to 10, 11, 11, 1. Now this packet, 192.1.20.2, right? This is the packet that was after the untranslation will reach to the R1. So now just check the the initial packet and the reply packet. It is matching, right? So he sent the packet to 20.2 and the 20.2 is replying to him. This should be one here. Okay, so that is the whole concept of natting, and that too is the dynamic natting, because this is not in your control. You define a pool and dynamically the IP address is assigned to that device that is trying to reach outside, right? So I have some points that I want to share with you. So this is for the NAT. Okay, translates private IP address to public IPs to conserve public internet IP address space. This is generally why we use NAT for private to public, but you can translate any IP to any IP. In Dynamic NAT, so we are talking about Dynamic NAT in this video, which is also called Object NAT or the Auto NAT. But in Dynamic NAT, you create a pool of public IPs, as I said. So this creation of pool of public IPs is called creating an object. So that's why we call this as an object NAT, because we are using objects for these things. And then you link it to an internal address that can use the pool of public IPs. So internal address can again be a subnet, a range, or a host IP address. Likewise, the pool that you create as for the public IP can also be a host IP, a subnet, a range. When the internal device tries to go out, it picks an unused IP address from the pool and translates it. So it's like dynamic, right? The next available public IP will be used. It keeps the translation in table known as the translation table. I'll show that. You can see it by show run xlate or show xlate command, show NAT details command. When the packet returns, the destination gets again untranslated back to the original IP and is sent back to the original device. That's what I showed it to you, right? So when you go from inside to outside, it translates the source. When coming back, it translates the destination. But that is not the case. So when you just, when you're working with the ASA, you just need to understand this concept of ASA. So for ASA, what subnet is local? For him, this side is local or the outside is local. For him, this side is local, right? So whenever you translate the local side, it's called as source NAT. So when the IP address came from outside, when it came from 192.1.20.2 as the source and destination was 192.1.20.12, he translated the destination, right, in this packet. But for for the ASA, this was actually the local side of the LAN, right? But this is not local. This is the outside. So again, this is source NAT. I mean, while as the initial packet, this is obvious. This is the local side. So that's why the source NAT. Okay, so it's a bit confusing, but you have to understand this with respect to ASA. Okay, so let me clear this and let's go and do this on the ASA. So if I go here on R1, enable and show IP route, if I see, I should have a default route pointing towards the ASA. I have that. And on R2, if I see show IP route, I have a static route that is saying this thing, right? So I need to remove this on the enable config key, do show run include what route. So I should have this, yeah. So I say no to this whole statement and this should be removed. Do right if I do, that is fine. Now on ASA, I should have a default route pointing towards the internet router. So I have that for any packet that has to be reachable, right? Okay, so what I'll do is I'll generate a telnet from R1 to R2. Let's do that. Let's do that before we do the NAT, and we'll see the difference. So on R1, as I have a default route, so this will be sending the packet to ASA again, being a TCP, high to low, it is going to send to R2. R2, I mean, is going to drop. Reason being is it does not have the route. Do show route. Okay, do show IP route. If I see, yeah. So I see that for 10, 11, 11, 0, I don't have any route, right? So let's do that. Exit debug IP packet details, and on R1 I will do the telnet to 192.1.20.2. That is R2. Now on R2 I should see some packets here, and let's do this all quickly. And yeah, so this should be you can see the source is 10, 11, and 1. This is R1. That means the ASA has has a connection table which says going to 23 on port 23, right? Reverse packet, reverse traffic is actually mentioned in the connection table, as I said. So the source was this one with the random port of this, and the destination port was this, right? So on R2, if you see, I have a source that is from 1 and destination is R2. You should see, I mean, destination is 23, that means it's a telnet packet. You should see a RIP failure, packet routed and okay, yeah, you can see. So routed via RIP, but it is failed, right? So because I don't have a routing, right? So let's keep it like this, and let's do the natting, and then we'll see the difference. Okay, so let me just explain to you how do you do the natting. Okay, so the configuration part, configuration of dynamic NAT on AC. So first thing first, what you do is you create a pool that defines the range of public IP addresses, right? That you have IP addresses. So just imagine my company is a rich company, and we have this whole range of public IP addresses. So you define this by object command network, object network, and then you define the pool, say my pool, and then here you have 3 options. You can say host, or you can say subnet, or you can say range. Okay, so if you have a single host, just say host, single IP of the pool, say host. If you have a whole subnet, say subnet, or in my case I have a range, so I'll say range 192.120.11 to 192.1.20.50. So I have this range. Next, step number 2 is you define the internal pool that will be translated related to the public IP. Okay, so and then also you define the and then define the NAT statement. I'll show you. So first you again do the same thing, object network, and then you say internal. This is my internal, and then you can also say a description here. Let's put a description as internal LAN. Okay, then you can do after that you have to again three options: host, subnet, range. So here I have the whole subnet, so I'll say 10.11.11.0, then the subnet mask /24, right? Now after that you have the NAT statement. How do you do the NAT statement? Just let me tell you the whole this, as I said, right? So this is the way you do it, right? High and comma low, and then you say dynamic, right? And then dynamic, and then the pool name, right? So how do you do that? So in our case we have the NAT, and then you have the inside high, and then the low is outside, then you say dynamic and my pool. So that is the case, and that's it. We don't need a security policy, because I will be trying from inside to outside, I mean low to high to low, and that to TCP, so the return traffic will be allowed because of the connection table. So let's do it on the ASA. ASA, first thing first, what I'm going to do is object network, and then I say my pool, right? And then I say range. So range, yeah, you can see all the options here. You have the range, you have the subnet, you have the host. So I'll be doing range 192.1.20.11 and 192.1.20.50. So that is the object. Now again I'll go object network, then I say internal. This is the name. Once done, you say again the subnet, this time 10.11.11.0.255.255.255.0. So that is the subnet. Now inside that you define the NAT. So you do inside and then comma outside, and here you have the option of static and dynamic. We are doing the dynamic first, so let's do the dynamic, and then hit the question mark. You will see that you have to I mean the pool or the group name, whatever you have. In my case I have pool, so you have to write this down like this, right? So now that you have this already configured, how to check this? So you can do a couple of things. Show xlate. You will not be able to see I think this is the earlier clear xlate. If I do so, show xlate in the dynamic, it should not be like this, because what happens is only when you initiate the traffic you should see the xlate there. So, okay, so this was there because of the earlier configurations maybe, and now what you do is you have another command, show NAT details, that will tell you the whole detail, okay, about the original subnet and the translated address here and the hits. So you can see we have not done any translations till now. You can see the hits are not there. For example, you want to see the running configuration, you say show a NAT, you will see the NAT, and also if you want to see the object, you can see the object. Okay, show NAT is also a command. You can see only the translations, and the detail will show the source and the translated address as well. So now enough of talking, let's do the same testing again. It will take some time for the translation. I think if you check the NAT details, you have a hit, you can see, but I think that will not be successful because the first packet gets stopped. Okay, so now I have the, I think it's Cisco 123. Let me check Cisco 123. Yeah, so I'm inside R2. So if I go here, if I check the show xlate, now I should have the translation. So I can see inside my R1, when going to outside, was translated to .18. Now if I go to R1, I'm telneted to R2, and if I say show user, this should show .18 logged in. Okay, let's see. Let's wait for some time, and I should see that the device that is logged in is .18. Yeah. So if I check again, I can check show con because I have the the telnet going on. So you can see that this is the connection. I'm not bothered about that. I'm bothered about this one. So I need the NAT that has happened is this one. Show NAT details also I can do. You can see the hits here, or even if you should see the NAT only, it will show the hits. So two commands: show NAT will show the hits, show xlate will show you the binding of that. Yeah. So that is how your internal private IP address devices are able to reach to the internet. And this is one part of it, which is called the dynamic NAT, or you can say auto NAT. Sub category of auto NAT is dynamic NAT. You have inside auto NAT, you have a couple of more NATs. You have the static NAT. So that we will see in the next videos. But for this video, this is it. And I hope you liked my video. You understood the concept. If not, you can go again and again, watch this video again and again until you understand. Best thing is to go on and practice this lab. Follow with me and do the things, and just experiment with yourself. Okay. So anything else, just comment and ask me. And please don't forget to subscribe to my channel, share these videos, and comment. Thank you very much. Bye bye.